deadlines are not hard. They're suggestions. But to be aware that there is an end of the semester at the end, right? So I will have to submit marks eventually. I won't. Essentially, yeah, in principle, if you can do it by um, um, the Monday of the recess before the study week, right? By that Monday, that would be great. All right, so essentially all files have, I've 4 assignments. I owe you another one. I want to come up with a new assignment that is going to be based on the game that we're going to be developing. And I want to go through the game first and then see exactly what would be a reasonable thing to ask there. The current 4 assignments, they have a certain template, right? It's the exercise which tells you what you need to do, and then there's this template of a function that of a method or procedure whose body is pass. Pass is the instruction that does nothing, right? So this file, if you put it through Python, if you load it in Python, it trivially loads without any errors, but also it does nothing, right? And what you have to do is replace this pass with with your solution, essentially, so that whenever this executes, this is the output, right? So you have a few examples for each of the exercises, right? So here again, right, you have to write this function, and when you have diamond 3, you should have an output like this. Obviously, notice that the comments don't need to appear as part of the output, right? So actually, the output should appear like this, right? Imagine that they are deleted. But if I don't comment them out, then the file will not load, right? So diamond 3, diamond 7, diamond 15, right? Same here, diagonals, and you replace the pass, and then whenever I run this, all right, I should get something like what you see here. Okay, and that's the pattern for all of them. You solve the assignment, and then I would like you to change the name of the file as you submit, and in the name, your metric number should be obvious, right? So ideally, it's just metric number.py. Because otherwise the file will try to avoid name clashes, will rename them somehow, but then I can't automate easily, your marking procedure. So I would like that your metric number is a searchable substring of the title of the file. Clear? Questions?
We only have 4 assignments.
No, there's going to be a 5th one, but the 5th one is going to be based on the game, and it's probably going to be, we're going to see the game environment shortly. Yes?
How should we separate, if we're just having our metric number in the title, how are we going to separate out assignment 1 versus assignment 2?
You're going to be upload. Yes, so they have to be in the title. Yeah, so you can say your metric number underscore assignment 1, or assignment 1 underscore your metric number, right? As long as your metric number is there. So I have a piece of code that will look at titles and will try to search for metric numbers in the titles, and as long as that works, right? As I mark, I'm going to go in here, and I'm going to make a certain comment in the code with, what marks each problem has, and then I have a script that automatically computes grades. Okay, so yeah, and the assignment is really not difficult. There's no need to be scared. Okay, marks are usually very high. A few years ago, I had a class where they dropped from 20 in the beginning to 3 in the end. And I never quite understood why. But anyway, like, the material might be a bit hard and fast-paced, but rest assured, the assignments are not that difficult. Okay, so today's lesson, what I want to do today is start a new file. I want to talk about the other data types that we haven't discussed about yet. All right, which is lists, sets, dictionaries, and strings. Okay, is this font okay? And we're going to start talking about strings. So let me save this, and here, Python, and this should be week 2, Thursday, right? Before we proceed, another thing, before I forget, next week on Thursday, so Monday, no problem, we're going to have the regular class. On Thursday, I have to go on another trip to India, just for Wednesday till Friday. And I'm going to have to make up the class in the study week. So that's one possibility. The other possibility is to just upload a video recording of the class. I would prefer, however, not to do that because I'm going to be doing some new material this year. Somebody's bugging me. Let me just tell him to. Brett, can't talk right now. Can I call you in an hour? Sure. Yes, I'm teaching a class. Take care. Bye. Sorry about this. I know this guy is going to keep calling until I answer. So, all right. So, did I put the pie here? I think I didn't put the pie here. So yes, I would rather make up the class on the Monday in the reading week. Hopefully we get to go through all the materials properly. Is that okay? Yeah. So remember, 1 week from now, no class. Strings. So as usual, I'm going to introduce strings very quickly, just through a few interactions. We need to be able to handle characters, right? Outside of numbers, not just numeric information is important, but also textual information. We will need to be able to handle, people's names and various attributes that can only be described as non-numbers, and typically we call those strings. A string is an entity containing quotes. ABC in quotes is a string, and we can have either double quotes or single quotes, and they make no difference, right? I can say ABC equal ABC, and I'm going to get true. All right, I can put anything I want, literally, including smileys and strange characters that cannot be found on the keyboard or cannot be found on all keyboards. Some of you have keyboards in other languages. You can put those in as well. And there's a variety of ways of obtaining other characters that you can put in strings. So for instance, this would be a valid string. All right? Yes? You can quote a double quote inside a single quote, and you can quote a single quote inside a double quote. All right? And if you need both of them, you can use backslash, right? So you can quote a single quote inside a double quote, or vice versa. Or you can do this. All right? So you can use backslash in front of a character to say, this is the character I mean, and it shouldn't have any special meaning. All right? And it's important to be able to handle arbitrary pieces of text. Now, what do we want to do with arbitrary pieces of text? Well, let's say we have a piece of text that is a phrase, hello there, let's say, right? And this is a string. We can give it a name, greeting, right? And then as we know, one thing we can do is say help greeting, right? But since it's a basic data type, Python doesn't have a lot of help for it. But we can say dear greeting, and we can find out a bunch of operations that we can perform on strings. All right? So let's take them one by one very quickly. All right. So, for instance, we have capitalized. Forget about the ones that have underscores. They're supposed to be secret, right? Secret. Actually, secret is not a correct word. They're supposed to be private. So they're supposed to be known by people who develop the string as a data structure, not by the clients, which is what we are in this context, clients of the string. So, for instance, if I say greeting.capitalize, right, it will capitalize the first letter, which is already capitalized. So let's redefine this as uncapitalized, and then greetings capitalize will capitalize it, right? Each of these operations will produce a new string and not change the old one, right? Greeting is still the old string. String as such are immutable. You can't change them. All right. I'm going to actually not look at each and every one of them, but just several. For instance, we have start with and end with, right? So hello there, greeting dot starts and hell, and it's true. Help, it's false, right? And similarly, there's an ends with, right? Ends with air, and it's true. Where, and it's false, right? Let's find a few more interesting operations. For instance, we have the split. So let's say we want to take a phrase and split it into words. So we can say greeting.split, and typically the separator between words is space, right? And you see that we get a sequence of words, right? Separated. We can do the following. So let's assign this to a variable called words, right? So now words is this sequence of strings, each string being a word. So we can put it back together, right? But that is a bit weird, right? Weird. Let's see how. So what do we want to put in between them? Let's say what I want to put in between them is a comma and a space. So I'm going to start with a comma and a space, and I'm going to say join, and I'm going to say words. And this will take all the words and put the comma and space in between, right? So we can, in general, split phrases and reassemble them together. All right, we can check various properties of a string. For instance, is lower of a low case letter will be sorry, A is lower. We'll say true. If I have a capital letter, it will say false. If I have something that is not a letter, it will also say false, right? So we can check various properties of a string. We can check whether a string is a digit, okay? And so on and so forth. And all these predicates are useful in writing code. So let's try to write a function that counts the frequency of letters in a string, right? And before we start with that, strings are also sequences, right? So if I have our greeting, right? Greeting 1, sorry. Greeting 1 is E, right? Which is hello, H is the 0th letter, E is the first. And I can take greeting from 1 to 5, and I'm going to get all the letters starting with 1 and ending with the 4th, right? Because the 5th is exclusive. It works very well with negative numbers as well, which you see that. So -4 we count from the right side. And so on. So it is a sequence. So we can always regard a list, a string as a sequence. So now, can you think of a very quick way of splitting a string into its letters? Let's say I want a tuple containing all the letters in a string. So for hello, I would like to say H, E, L, L, O. How do I get that?
Within the split parentheses, then 1, 0 to the last letter.
So I told you something about sequences last time, right? Sequences are convertible from one to the other very easily. So if I want a tuple, I have a sequence and I want a tuple, I just say tuple of hello. Okay? And if I want a list, I can say the same, list. Right? Which is why people like Python so much. Right? Alternatively, you could say tuple of character for character in hello, right? You'd get the same thing. So now there's an interesting inconsistency in Python, right? Because you see, if you take the list or the tuple or a tuple of numbers, the inner elements of the tuple are numbers and not tuples, right? But for a string, the inner elements of a string are singleton strings. If you look at other languages which are consistent with from this point of view, right? Strings are made up of characters. So the unit for text is a character, and then I can have a sequence of characters. So when I go from sequence, which is the string, to individual element, I go one level in, right? I go from string to character. And the character itself is atomic, is no longer decomposable, right? If I go from a list of numbers to the number, again, the number is atomic, cannot be further decomposed. But here we have an inconsistency, because a string is made up of little strings, right? And you could try to further decompose the little strings, just that there's nothing inside, right? But that inconsistency can cause trouble, and actually often does. Nevertheless, let's try to write a function that counts the number of characters, the frequency of every character. Or no, so let's start with something simple. The frequency of a given character. We want the frequency of a given character, and we're going to write this in a few ways. So def frequency, and we take a string, and we take a character, and we want to return the number of occurrences of C inside S. Okay? So, a very simple way.
Can you like look up into the string?
Yeah, we can. But I like to start with the simplest way. All right. So I have this tuple of hello, right? It has two L's, right? So, and actually inside here I'm going to say one if C equals L, else 0 for C in hello. So what am I going to get here? I'm going to replace every character with either 0 or 1, right? Now, if I want to count how many L's there are, what do I need to do? Add them. How do we add them?
You can create an empty list.
That's Python, right? So in Python, everything has to be very simple. So sum, and I'm not going to even write a tuple now, because I actually can go here and say this. Okay. So if I want to write it here, how am I gonna do it? We have one if C is equal to, let's call it D, else 0 for D in S. Right? So we're going to get into the habit of writing tests for our code without actually, I mean, we want to see the output, but we want to also test the output. So our expectation is print the number of the count of L in is, I'm going to say frequency of hello and L. All right, so now we can go here, and as we used to before, right? There are two L's in hello. And obviously, we can make this test as complicated as we want. So let's pick a. So typically we're gonna to make things even more streamlined. I'm gonna say test word or test phrase equals hello, and test character is L, and then the count of test character in test phrase is frequency of test phrase and test character. So something is wrong here, test phrase, and then here we have too many quotes. All right, so then if we have done this, we can just copy this piece of code, and we can just change here test phrase, the quick brown fox jumps over the lazy dog, and O's appear a bunch of times, right? So we want to see how many O's are there in that phrase. So now as we run, test char, sorry. All right, so you see that because we have sort of given a name to our test data, right? It's very easy to create new tests. We just have to copy and change those names in only one place. So let's try solution number 2. All right, so let's do it like old style. So let's have a count, which we initialize with 0. And then we're going to say for, and we're going to learn new parts of the language now. For character D in S, if C equals D, count plus equals 1. Return count. Okay, so this would be another way of doing exactly the same thing. So I'm going to copy the tests. And we're testing frequency 2 now. All right. And yes? We're incrementing count by 1, right? So if C is equal to D, right, we're incrementing count by 1, right? So count goes from 0 to 1, from 1 to 2, every time we're encountering a occurrence of C. All right, so we're going to put a separator between the outputs. And then we're going to see if we get the same result, right? And you can see that this output is the same as this output, which means that the solution is probably correct. Okay. Can you think of another way of doing it? Yeah, let's try another way. So frequency 3. Freq3 of S and C, right? So we're going to iterate with an index starting from 0 to the length of S, right? So we're going to say similarly count, it starts at 0, and now for I in range of 0 to len of S. And what we do is if C equals S I count plus equals 1, return count. Okay, and this is probably all the possible ways in which you can write the frequency of a character. All right, perhaps a more interesting thing would be the frequency of a word in a phrase. Let's, before we do that, let's test our function. All right, so we see that it works correctly. So let's count the frequency of a word in a phrase this time. And there was a phrase that had 5 occurrences of the word of. Can I get it? Do you know this? There's a phrase where most people count only 3. There's 6 occurrences of the word of, and most people find only 3 of them. And there's a psychological reason for that. So I would have liked to, it would have been good to have that phrase ready. But let's just take an arbitrary phrase. All right, I'm going to start from here and go here. And I'm going to start by conceiving the test. All right, so we're going to create a string that has a lot of words. Strings can be concatenated with plus as all the other sequences. I am going to remove arbitrary and leave spaces nevertheless. And maybe we don't need a lot of words. Maybe 4 or 5 lines are enough. Okay, maybe this is enough. So I'm going to create this testing piece of data. And I'm hoping that there's one word that appears quite frequently, something like the. The appears quite a few times, right? So this is going to be our test string. All right, so let's define a function, word frequency. So we have a string and we have a word, right? So how do we get now the frequency? We can use one of the 3 functions, right? So can we use this one? Pardon?
We can just put a word.
So can I say return freq?
When
Yes. We have a test character as well.
Okay, let me make the screen larger, and let me bring this close.
one words.
So I would like to provide 2 arguments here, right? This function freq takes 2 arguments. What would be the first argument?
Test string. That's the
But you're
paragraph,
counting
right?
the word frequency, and you're gonna define which one.
But that should be W, right?
That's the entire. Can you check us a whole word or do you need character by character?
I just want the word, right? So for instance, the word the appears 1, 2, 3, 4, 5, 6, 7, 8 times, right?
So
Twice on every line.
S is the entire paragraph.
S is the entire string.
So it's a test string.
No, but I can't put test string because then it will only work for test string. I want to work for arbitrary strings.
Then you
And W. So the interesting thing is that you see this function doesn't really care whether C is a single character or a full string.
So that's just gonna split it after every space, right?
Yeah, which is how we define words to be, right? So so then let's have another test. Right, so we have our test string and our test word is the. So the count of test word S in. So now what we're going to want to do is essentially, because it's a multi-line string, we're going to want to separate with a few empty lines. Right, so I'm going to say \n here is, and we're going to have word frequency and test string and test word. Again? Test string is defined. Between the new lines, this should be test string, yes. And let's be consistent and call this test word. This one is not defined. All right, so the count of the, it's not so nice, is 8. Okay, something like this, right? So the important thing is that we want always to find opportunities to reuse our code. We don't want to write from scratch. All right. Now, the list data structure is very similar to tuple, just that it's mutable. All right. So I'm going to do a similar exercise where I want to count digits, right? And we're going to use a list for that. So very quickly, I think we've already looked at this aspect. Right, so I can start with a list L, let's say, of numbers, right? And it's still a sequence, does everything a sequence does. Sorry, colon, right? But on top of everything, I can do things like L2 is assigned 10, and then L has changed, right? That's not possible with a tuple. Okay, we can also extend it. So I can say L dot extend of 4, 5, 6, right? L dot append, I can append a single object, 100, and so on. So L can be changed. So one interesting thing would be now to have a string that contains only digits. So a string that contains only digits. And we want to count how many digits of each type, of each value, are there, right? So I'm going to record this into a list where the first element is the count of zeros, the second element is the count of ones, the third element is the count of twos, and so on, right? So for instance, if I have the string, right, what I should get is how many twos are there? How many zeros? There's 0 zeros, right? Let's put a 0 just for right? So there's 1 0. Actually, let's make a a list that I don't want to keep counting. So 1 2 3 0 5 4 2. So there's 2 2s. 1 6 7 8 9. Yeah. So there's 1 0, 2 1s, 2 2s, 1 3, 1 4, 1 4, 1 5, right? 1 6, 1 7, 1 8, 1 9, something like that, right? So this is what this would be the output. Okay, how do we go from the string to the digit? That's an interesting question. And let's solve it here, right? So I have the string 0. This is not the number 0, right? So the string 0 plus the string 1 gives me the string 0 1, right? Whereas the number 0 plus the number 1 gives the number 1. So there are different things. Okay, so going from one to the other can be done with a function that obtains the code of a character, which I think is called ord, follows Pascal, right? So if I say ord 0, I would get 48, all right? Each character will have a code. Where do these codes come from? Well, they come from here. No, sorry, I'm taking you to ASCII. So computers use numbers, right? When, for the first time, people wanted characters to be handled by computers, they took the list of all of the characters that were of immediate need and gave each one a code. And let's see if I have a nice table somewhere, because that table was the old one. Printable characters. Okay, so and they came up with a list of 127 codes. The first 32 being control characters, right? So they're not important in this. Historically, they are, but they're not so important nowadays. So starting at 32, right? 32 was the space character. When you press the bar on the space bar on your computer, right? The code 32 is actually issued, right? The computer doesn't see the character, sees only numbers, codes. And 48, if you see here, is the number 0, right? And this makes it easy to perform computations about characters, because you see these numbers are in sequence. So 0 is 48, 1 is 49, and so on, right? And actually, 48 might look like an odd number in decimal, but in hexadecimal it's 30, right? It's 30, so it's sort of a round number. And if you go to characters, to letters, right? Letters start at 65, but that's 41, right? And you don't want to start at something with 0 because you're considering A to be the first letter of the alphabet and not the 0th, right? So they start at 41 and they keep going, 26 letters, right? And then the letters, the small letters, the small cap starts at 61. So the difference between any character and its corresponding capitalized character is 20 in hexa, which is actually 32, right? Which is a nice thing. So whenever we do we do 2 lower, right? You've seen that one thing I can do is a dot lower, right? How is this computation performed? Actually, we can say chr of ord of a minus 32, sorry, plus 32, small a here, right? So from small a to big A, I just convert this to the code, I subtract 32, and I convert the code back into a character, and I'm going to get the conversion, right? So this is what happens. Now, how do I convert the character 0 into the number 0? Right? Well, I'm going to, so let's say I take the number 3, right? How do I convert the character 3 into the number 3? Well, I'm going to take the ord, the code, and I'm going to subtract the ord of 0, which is 48, as you noticed. I'm good. I'm going to get the number 3. Why is that? Because they appear in sequence here. So I don't need to remember. I don't need to remember which one is the first. I don't remember that it's 48. Right? I don't care that it's 48. To reach at the number 3, I'm going to take the character of the code of 3 and subtract the code of 0, right? And I'm going to get 3 out of it. Is that clear?
So why does it automatically convert it to 3 instead of returning the number of the
What do you mean?
um,
No, so ord 3 is going to be 51. But to me, 51 is just a code. The only thing I need to remember is that they are in order. So to get the 3 out of the string 3, I just have to subtract the code for 0, whatever that may be. Because the code for 3 is going to be 3 codes away from the code from 0, always. Right? So if I have value, so if I want to define value of a character, right, I have to return ord c minus ord 0.
oh, so it's just a formula.
Yeah, it's just a formula, right? So now val 3 string. Yes? Everybody understands the distinction between character 3 and number 3? No? They're encoded differently, right? I think you can use the int function as well. But then that makes it that makes it less interesting. Okay? So remember this because it will come up. Again. All right, so so let's do that. Let's try to, assuming that the string contains exclusively just digits, let's count digits. So we have a string, and we want to return a list of frequencies. All right? So I'm going to start with a list of 10 zeros because initially I haven't counted yet, and then the frequency of each digit is 0. And this is another very interesting thing. I can say a list of a singleton 0 times 10. And that will create a list of 10 elements, each of them being 0. Okay? And then for C in S, all right, what do we do? Right? Plus equals 1. Yes? Increments by 1. So a very frequent thing in programming is writing things like x equals x plus 1. So I'm changing x to be the old value of x plus 1. So if x is currently 3, I want to make it 4. And often you don't want just 1. You might want 10, or you might want some other quantity x, y, right? But you are taking the current value of x and you're adding to it some quantity y, and you want to store that new result back into x. There's no reason to store it somewhere else, right? So whenever you have this, it is a lot more convenient to write plus equals. This is a shortcut for x is assigned x plus y. Just increments x by y units. Okay, so we are here incrementing the array element, the list element, residing at rank equal to the value of the character by 1. Yes? Okay. Return frequency, sorry. All right, and very quickly, let's do a test here. So print test, sorry, this should be a string. And we have count digits of and that's it. Okay, so let's see what we get here. Right, so we have no zeros, we have no ones, we have two twos, right? One is here, another one is here, right? We have two threes. One is at the beginning, the other one is close to the end, and so on and so forth. We have 5 nines. So let's just verify that. 1, 2, 3, 4, 5, right? So it's correct. Yes?
Can you go back to the code for a second?
Yeah. Now, obviously, if you want to go here and replace this by int, this will work in C. This will work equally well.
How would we add something that will return an error message if it's not contained with digits?
So this will return an error message.
Like, not the int, but if we write using order.
All right. So if I call it with count with so let's say we have digits and we have some non-digits, right? You're going to see an error message right away saying list index out of range, right? Because this int will return none when it encounters a not digit, right? And at that point you get an error because the list only has 10 elements. There's no index called none. Okay. Now you may want to be more friendly, right? So you can say if C dot is digit, we do this. Else return in which case right, we get back wrong, don't have a argument.
Would it do the same thing? Would it return the same error if you use order, the function that you defined in the beginning? Like,
Yes. Because the test is on C being a digit, right? Has nothing to do with how this rank is computed, right? Yeah.
How would you separate out non-digits from the string if there were non-digits?
If they're between 0 and 9, right? So let's say I don't have a digit and I want to define my own. My is digit of a character C, right? Return ord C greater than ord 0 and ord greater equal, right? Because 0 is actually a digit. And ord C less than equal ord 9. And the conjunction in Python is the word and, right? So my is digit 4 is true, my digit of x is false, right? But, right, so you know that we have 4 dot is digit, and right, so pretty much any category you have, right, so 4 I can say is alpha. So checking whether it's alphabetic, sorry. C is alpha, is true, G true, right? And actually you can do it for multiple characters, right? So if the entire string is made of alphabetic, then it's true. If you put a non-alphabetic character in there, it's false, right? Dollar falls into the category of special. Oh. If numeric is lower as identifier is decimal, his space is title is upper. Oh, actually it doesn't have a it doesn't have a predicate for special characters. Interesting. Most other languages do. So is special is a standard in most other languages. Okay. But you can see them, right? So is decimal is digit, and so on. All right. Let's do the same for words. And I want to introduce a new type of data called a dictionary, right? So arrays are, or lists, right? What are they? They're actually functions from a range from 0 to the length of the list, right? The arguments are these numbers, and the values are whatever resides in the list at that rank, right? So there's no good reason why we should be restricted to numbers, right? We could create a kind of collection, a kind of aggregation where arguments can be anything and the results can be anything, right? A function is pretty much like that, but we want something that can be modified on the fly, right? So we say that a dictionary is in fact a collection of key value pairs. There's a key that maps into a value, right? Whenever I pass in the key as an argument, I get back the value, and I can add new key value pairs to the collection on the fly, all right? Or I can change the values corresponding to a key. So let's experiment a little bit with this, right? And we're saying it's a collection, but it's actually a set. So we're going to use curly braces for that, a dictionary, right? And I'm going to say that there's a mapping from A to number 10. To number 10, it's colon. And for B, there's a mapping to 20. Right? So D is a dictionary. And I can say DA and get back 10. Right? I can say DC, which is not a key in the dictionary, and I'm going to get an error. But I can say D.get C, and I'm going to get nothing back, right? So D.get has the very nice property that it returns nothing when there's nothing there, and it returns whatever is there when it is, right? It doesn't return an error, and this is sometimes very useful, right? So how do you check? There's nothing being returned, so you can actually be more proactive in saying is none, and then you're going to get through. So it would be interesting to count the frequency of words now, right? One nice thing about using dictionaries that I can increment this, I can change this value, right? And now D contains a key that for the key A contains the value 11, and the other ones stay unchanged. I can also add on the fly a binding for C, and now D contains dictionary D contains a binding for the key C. Keys are not restricted to strings, so I can put I can also put a number here, 1. All right, so D1 is 100, and whenever I have numbers, they don't have to be in sequence, they don't have to be part of a range, they can mix with anything else. I can put as a key pretty much any immutable structure. I can't put mutable structures, right? So therefore a tuple, if you remember, is an immutable structure. So I can say tuple here, 3 and 4, and I want to make this a string, right? Succeeds, and we have this, right? And we can go in and say D of 3, 4, and I get back this. However, if I try to replace this by a list, right? A list is mutable. It'll say that it's unhashable, whatever that means. I'm not going to go into that, but cannot be done, right? This is very useful because it allows you to search for stuff. Dictionaries can be very large, can contain millions of elements, right? Millions of bindings, and then, like, for instance, you can put in a dictionary between 2 languages. You can have the word in English and the word in Japanese, the corresponding word in Japanese or whatever language you'd like to have. All right, so we're going to try to use this to count frequency of words. All right, and I'm going to use this name FreeQ S, sort of suggesting the plural. And we're going to have a string S, and we want back a dictionary where every word appearing in the text is a key in the return value in the dictionary, mapping into the frequency, into the count of that word in the text, right? So we're going to start with a dictionary. Which is empty initially. All right, so this is how I create an empty dictionary. If I remember correctly, we can also create it as like this, right? So E is the empty dictionary, and E A equals 1, and sorry, E now is okay, right? So we can create it like this, or we can create it by just empty brackets. And they're going to ask me why not the empty brackets, or the brackets represent a set, which is what is typical of math. Well, a dictionary is a set of bindings, and then if I make those bindings from a key to a Boolean, to either true or false, actually I can represent a set, right? Trivially. So a dictionary degenerates into a set when the values are Booleans, right? So it becomes the set of keys. And this is what actually sets are. We can work with sets, but they're nothing but dictionaries where the values are Booleans. We're going to do the same trick in order to get the set of words. So for word in S dot split by space, right? And we would like to do dw plus equals 1, right? But this doesn't work if dw doesn't exist, right? So we have to check. Right, so we're going to do it in the following way. We're going to say dw is equal to 1 if d dot get w is none, else dw.
What exactly does that line mean?
Again?
What exactly does that line mean?
So if d.getW is none, means that the previous frequency counted up to this point was 0, right? We haven't encountered this word before. Then we are currently encountering it now, so its count should be 1. Otherwise, if this is false, then this frequency, dw plus 1. Okay, so this frequency, which is the old frequency, should be incremented by 1, right? And we return d. All right, and let's create a test. So I'm going to create. I'm going to use this test string and the word frequency. In test string is word frequencies test string. That's not what I wanted, but it's pretty much there, right? So I don't want it interactive. right? And we should have added some new lines, right? So one thing that would be nice here now is to print this dictionary a bit in a slightly more legible fashion, right? So let's first of all put some new lines, and then let's add something that def print a dictionary D, and then we're going to do for key and value in D print word key frequency I don't need this. I would need this. And then we can go here and say print nicely. And let's see what we get now.
Hey, we have this costume booked.
Yeah, I'll be out in 1 minute.
Perfect. Thanks.
Thank you. Maybe I didn't save. Too many values to unpack. I can't remember how it works. Let's finish this next time since we're being kicked out of the room. Yeah. If you have questions, let's do this outside.